Okay, so what I'm doing real quick is go over some basic code, some system calls and whatnot that's going to be pertaining to doing actual file handling in systems level C. To note, this is going to detail specifically some low-level C ways of handling files, so it's going to be very, very different than your typical C ways of doing it. So things that you might be used to, like fopen, fwrite, anything like that, that's not going to be detailed here. We're going to be doing basic read, write, open, and all those other variants of that. So, without further ado, let's go ahead and take a look over. And again, this is just basic file handling. We're not doing anything, um, I guess, advanced here. It's just kind of glossing over some, again, basic file handling. So, first thing we have is file descriptors. So in C, these are integers that uniquely identify open files that are incrementally stored in a file descriptor table that each running process uniquely has. So we're going to get to a point where you have multi-signal applications, multi-thread applications, whatnot, FIFOs and stuff like that. So you'll start dealing with applications that have multiple process IDs for the processes that we are going to be running. Each one of these is going to have this FDT, this file descriptor table, that has all of their own entries that are associated with what files that current process has identified. Of each one of these file descriptor tables, the first three entries will always be the same. That is the standard input stream, standard output stream, and the standard error stream. This will always be consistent for processes using C. Now, it is something a bit like this. So as you can see, I have two processes going on. So I have one at PID 16,752, and then one incrementally after that, 16,753. Both tables, the first three are the same thing I just said: standard in, standard out, and standard error. That is how they would always start. Beyond that, this would be files I've opened, created, something that I am currently accessing for that particular process. So in the left side, you can see that I have something in my home directory, a sample directory of a file called input.txt. And in my other one, it also has the same file. So you could have them accessing the same file. It's perfectly fine. You have to be a little bit careful there on if you make changes in one process that they're going to be reflected over in the other one. But that's okay. The process will have a way of identifying it through its file descriptor table. Now, in the fourth entries down here, you'll see that 16,152 on the left side has out1.txt, and then 16,753 has out2.txt. So this one, these entries are now pointing to two completely different tables. So if I try to do anything with out1.txt with the process on the right hand, I wouldn't be able to do that because I haven't identified it yet, essentially. I don't have access to this file using this process. Same way, if I try to do anything with out2.txt using the left process, I wouldn't be able to do that either. I'd have to actually manually open that file before I have access to do anything with it. Now, file system calls, in this case, this is systems level C programming, and will often steer clear of file pointers that most of the functions you'll see in the standard IO header file, they often use things like fopen, fread, fwrite, etc., etc. We're not going to be using those because they are not signal safe functions. The file pointer aspect can get very messy, and it's much safer to use the lower level open and read from the universal standard one over here, so the UniSCD, The open, read, write, whatnot, those are all considered signal safety, and they work very, very well with Unix operating systems. That file descriptor table is very, very robust. It works remarkably well. It is a bit more work, as a lot of things in systems level programming is, but it's honestly not too bad. So before we can do anything really, we need to look into creating files. And there's two ways of doing that. There's one very common one that's, well, let's say it's common. It's not the most common. There's one that's directly created, well, I guess for creating files. But then you also have another one that is the more common one, albeit a little bit unintuitive. So I'm going to go over both of those. Both are perfectly fine to use. Also on a note, when we create files, we are also going to specify their permissions for after the program is run. So every time you create files, you have to do file permissions. Again, that's 644, 755, 777. Don't do that. But we're going to default to 644 because that's what your basic applications like Touch and whatnot also use. And it's just ubiquitous. It is the safest way of setting permissions that are going to be widespread usage for all your users to be able to read that file. And that's the bare minimum you usually want. So that's what we're going to go with. So the first one of these system calls is create. Yes, I know there's no E here, so it looks like create, but it is create. So the whole point of this entire call is just to create a file with some form of permissions. So it's honestly very, very simple. I do have the actual man page here if you'd like to look through that, but essentially we have the actual system call of create or create. You have the path, and then you have the actual mode here being the actual file permissions. So if you look on the right, header files here, so it's literally just one line. Create, making a sample.txt file, and I'm just giving it permissions of 0644. Now, the permissions here when you do create or the next one, when you're making files, you need a 4-digit number for the mode. We've only really discussed those last three, the 644, 755, etc., etc. And I did mention there is a fourth digit. We are not going to touch on that digit too much. It is more into low-level system administration stuff, if you have a bunch of users and whatnot on a single system. But if you don't specify that fourth digit of 0 or 1, it's always 0 or 1, then it will give you really messed up permissions. So even though you only really care about the last 3 digits, you still need to specify all 4 digits when you're calling create. All right. And then it returns the first unused file descriptor. So again, the first 3 file descriptor entries is the standard input, standard output, standard error streams. And then the first unused one is the next empty entry. So again, 0 is input, 1 is output, 2 is error. Oop, there we go. And then whatever starts here, so your third entry, that would be whatever sample.txt here is. That would be that file. So if I made a new one, so if I call it create 3 times here, that would be entries 3, 4, and 5 in my table. If I fail to create for whatever reason, it will return a -1. So beyond that, this is not creating a file. This is going to be our make directory command. Normally I don't add this too much, but it's so similar to create that I want to go and put it here. It's literally the exact same thing, except for instead of doing create, you do mkdir. Very, very similar to that basic command. It works the same way. You create a file, You specify the permissions. We usually do 0755. If you do the actual make dir terminal command, it uses 755 by default. And it'll return 0 if it's successful, -1 on error. So if you need to make your own directory, this is how you do it. Standard library, and then the system stat header file. I'm going to try and make the bare minimum header files appear in the sample code, so not a big deal. All that detail is in the actual man page as well. Oops. Okay, this is the second way that we can create files, and it's often used this way because you have a choice to either open it or create it if it doesn't exist. When it comes to create, you specifically only want to use that if, one, you are intending to create a new file all the time, or two, you don't care about completely replacing the contents of a file. Now, command open is used to open files, but it can also create them if they do not exist already. It has 3 parameters, which is the path, that's the file to open. Flags indicates how we open that file, more on this in a second. And then mode, which we had in create, that's the permissions of the file. Again, we commonly use 0644. So it returns a first unused file descriptor, just like create, or -1 on error. Now, if we look at it, we have open as a system call, not a big deal. Sample.txt, just like create, to specify the file I want to make. And the big difference is this right here, this O_WR only, that's open write only, or open create, or open truncate. So we are essentially making a collective of these flags, essentially specifying how do I want to open this file, and what mode am I doing it. Well, not what mode, but not permissions, what type of way am I intending to interface with this file? Because technically mode is the actual file permissions of 0644, just like create. Now, write only, obviously I'm opening this file and I can only write to it. I cannot read data from it. Create, that's specifying I want to create a new file. And then truncate is basically going to delete all the content of the file. These collection of flags, they equate to the aforementioned create functions functionality. So this one call here is the equivalent of calling create. So that's why I said you only want to use create if you're intending to create a new file and you don't mind basically completely wiping the data from it. If you have any intention of reading a file and you don't want to fiddle with what's inside of it, you don't use create. You will use open by itself. And a lot of people just default to using open because that's what they're commonly writing already, because they're opening in read mode and read write, etc., etc. So a lot of times create gets overlooked. I just think it's good because it's pretty short and it's very, very specific on what is it doing. So I like it, but open you'll see very frequently. Now, I have a small collection of open flags here. That is the more common ones that you'll see. Until you get to like signals and whatnot, this is the 6 that I think are probably the most appropriate. We have the first 3 being what type of mode it's going to be opened in. So it'd be read-only mode, write-only mode, or the ability to do read-write mode, where you can read from it and write to it, which I think is pretty cool that you can do that. Obviously, you have create. That's if you want to create a file that doesn't exist. And then your last 2 are what are you doing with the data inside of it? Do we want to keep it? That would be opening in append mode, which puts the cursor at the end of the file. So that way you don't potentially completely overwrite everything. You're just adding new data to the file. Opposed to truncate, which is opening the file, deleting everything, and then setting the cursor to the start. This, if you wanted to basically wipe everything from a file, like start from anew, you would open in truncate mode, and that's it. So be careful with that one. This is specifically when you're opening a file, this is telling the program how you were intending to interface with that file. And beyond that, we have close, which is the exact opposite of open. And on that note, it frustrates me because in a different header file than open, So you'd have to have more header files to be able to open and close simultaneously. And I just find that frustrating. So it just takes one parameter, and that's just the file descriptor. So in this case, you see I have int fd1. This is the file descriptor for this file of sample.txt. I'm opening that file in read-only mode. It is adding it to the file descriptor table, and it is saving the entry to that file descriptor in the integer fd1. So now it's saved as a variable. If I were to print that out, it would actually print out 3 because 0, 1, 2 are taken by the input-output streams. So when you get done using a file, you want to close said file. You don't want to just leave files hanging open. That is very, very bad behavior. So when you open a file, do what you need to do with it. Once you are finished, go back and close it. This just returns 0 if it's successful and -1 on error. And then finally, this one is not necessary, but since we've already talked about creating and opening files, I just discussed closing, so I figured I would give the, I guess, converse to creating, which is unlink, which we use to delete files. So let's say that you make a file temporarily for the program and you get done with it, and then you just want to clean it up when you're done with it, and as opposed to like leaving it hanging or something like that, you would use unlink. And essentially that is going to remove that directory entry. So it unlinks it from the system. And all you gotta do is just do unlink and then the actual file path. You don't have to deal with file descriptors or anything here. I don't suggest unlinking files if you've left them open. You would want to use unlink after you do a close for sure. So if you open a file, close it before you try deleting it, just to be on the safe side there. Now, that again is just some basics on file handling. That's only going over the open and close aspect, creating them, deleting them. It's not really getting into the ins and outs of, say, reading and writing. That'll be in the next video I do. But I really want to go over kind of what the file descriptor table is, and then how to populate those tables by opening files, and then discussing the idea that when you open them, they need to be properly closed afterwards. So kind of isolated this into the actual basics, and then we'll get into the actual read-write aspect of getting input-output from both the standard input-output streams that I've talked about already, and then the actual files that you'll be opening and closing on your file system. So hopefully this video was helpful, get the actual basics of everything we're working with, and I hope you learned something. So I'll see you next video. Bye.